So I want everybody just to take a deep moment and to look at the title of the talk and to think about what that means to you. That's it. Good morning, good afternoon, good evening, which is appropriate since people around the world will be watching this. I wanted to talk to you a little bit about working through deploying observability into some of the lessons that came from that weren't necessarily expected, and some of the things that get away from the propaganda that we like to tell ourselves about how it works and how great it is. Because it is great, but it's not as easy as it might think. And where I wanted to start was talking about some of the things that Fred Brooks had to teach us. Of course, just passed away, but the author of The Mythical Man Month. And most people look at that book and they think about the problem of adding staff to a project, right? The major thesis of that work was, hey, you can't go and add more people to a team for the same reason that 9 people can't have a baby in 1 month, right? And so people think about that one, but the other thing is there's a bunch of other stuff snuck into that work, and even though it was written in the 70s, it's worth a read today. It's just like full of amazing material that can resonate to us so much later. And one of the points that's in there is not to do things a second time. That's not quite what he says. He says, beware of the second system effect. But really what it says is, don't do things over. And the reason I'm saying about this is that I was working at a conversational analytics company. And the product there was to take calls into call centers, recording them, and doing speech to text on that, and then an AI pipeline to do analytics on that. Now that's borderline a little bit kind of on the edge of what you might feel comfortable with. The reason that I was okay with working on a product that did this was because this was about making people able to work in the call center do a better job. And at the end of the day, all of us have to deal with large companies, and it's one of the principal channels we use to interact. And if we can make the experience of customers talking to agents in a call center, interacting with the companies that we're trying to get services from better, well, that's to the good. So I landed in this company, and it had been building for 4 odd years by a team of exceptionally talented people who didn't know anything about production. And they built this huge system, very elaborate, and it wasn't scaling very well. In fact, really, we had no idea what it was doing in production. There was infrequent releases were almost non-existent. The build system was insanely complex. Costs were spiraling out of control. And these are not uncommon themes. But in an environment like that, you almost ask the question, where do you start? Because for all that we would love to say, oh, well, we just want to have an analysis and fast builds and all the things that we would hold dear as the hallmarks of a good system, how do you put that in place when none of it's in place? And worse, people think they've got it, and yet it's not happening. So I wanted to sort of not go into the depths of negativity and actually say, observability worked in this situation. Absolute game changer. It took a team of people that had no connection to what was happening on the production systems and brought it back. And in fact, I'll just put this up. This is the kind of chart that we all live for, right? And it's real. We were able to make a change. I mean, this is the essence of engineering, right here on the screen. Make a change and know that change has had an effect. And it's a theme I'm going to come back to at the very end of this talk, but that is really quite key. After all of this, what is the point? We made a change. Did it have an effect? And that's a conversation that's not the purview of just the developers. It's not the purview of just the operations people. It's not the purview of just the business people. It's, well, let's try it and find out, right? Because so many occasions, we have these horrible religious debates about the best way to factor an algorithm or to deploy some distributed services or whatever. And at the end of the day, did it make a difference or not? Okay, so I'm going to go back to negativity. The bad news is that this whole business is harder than we'd like to think. The people that are selling observability products would have it that you can just quickly, easy deploy something, drop this Helm chart in here, or drop this little script over here and stake all the information and spurge it off to our product, and we'll display everything and it'll solve the world. I understand why vendors in this space have an incentive to make it sound easy, but it's not easy at all. If you've ever built a large system and tried to sustain it for time, or worse, inherited a system that somebody else has built, you've probably run into some variation of this theme. This is a paper from Peter Nauer in 1985, and the parts highlighted was actually, somebody tweeted this, and I just wrote it so it would be clear. A program can be dead and you don't know it. Yes, cue Monty Python jokes. It's unbelievable that so much of the systems and services and technologies that we rely on don't have anybody who's around who understands how they work. I mean, I've talked with several of you today who have got experience in corporate and banking and financial services, and they're all nodding knowingly, going, well, you know, there's all kinds of services, thousands and thousands of services and machines that people won't turn off because no one knows what will happen. The thing that I thought that was fascinating about this quote, though, is the bit at the very end that I didn't highlight, and that is that you don't revive a program until a new team develops a new theory of operations for that tool, system, product, right? And so this is where continuity of knowledge is everything, right? You either keep the system moving, keep the continuity of knowledge, share an understanding of how it works and why it works that way and why it was designed that way, or very quickly you will fall off a cliff and suddenly there's nobody left in the organization that knows why the thing is built the way it is, and it's lost. You might be able to run it for a while longer, but it's lost. And pretty soon, you're going to be staring at a rewrite. And as Fred Brooks taught us, you don't want to go there. And certainly that was my experience in my previous role. The reason I wrote it up this way is one of the things that Google innovated and gave us as part of what became SRE was the notion of error budgets, right? And the notion of creating a shared feedback loop between development and operations, as it might have then been called, to have a shared set of incentives around keeping a product in motion, right? And if, in the ideal world, if the developers are releasing and not breaking it, go nuts. Release as often as you want. When you crash out your error budget, the ops people are like, okay, that's enough, talk to the hand. You're not doing any more feature releases until you get your act together and we can operate this system reliably. That's the notion behind error budgets. I'm sure that the people that involved in SRE at places like Google would have a much more accurate description, but there you go, that's how it works. Well, here's the thing. You can either do that in the small, and I mean, admittedly, in an audience like this, everybody's like, oh, yes, yes, yes. But at an organization level, there's lots of people that would have no idea what I just said. And all of us nodding our heads would be also familiar with trying to explain this to our colleagues in the rest of the business, and they just don't know what we're talking about. But we either succeed in creating that shared incentive, or the program will die out in the way that I described in the previous slide. And you get to the point where you have no choice but to do a full rewrite. And that has a visible cost, and that feature delivery comes to a complete screeching halt, not for weeks, not till the next month cycle, but for months and months, if not years. Because that's how long it takes to do a full system rewrite. So we pulled it off. The long and the short of it is it took over 6 months for us to re-implement almost the entire code base of the system underlying this thing. And why were we doing this? Because I needed to know what it was doing. It had become so complicated. The old system was developed in a way that, I'll just give one particular example, was that they had, it'd been developed by a bunch of people who were out of, it's not really worth naming names because they were good people who built an amazing tool, an amazing, powerful system, right? They just didn't have the awareness of how that would scale up. And so they had used a database at the heart of the system. It was like 2005 was calling, right? But everything was in the database. They did their own queues because, we don't have those in cloud-native services, do we? The problem is that when you build like something where the database is the heart of everything, you end up wrapping types around those database entities, and those types end up metastasizing through the entire code base. And so any notion you might have of, well, I'll come along and I'll replace one service. You can't, because that one service is coupled to everything else. The coupling was effectively infinite. We talk about loose coupling, tight coupling. This was beyond that. Nothing could change in that code base without needing the types from everything else. And you see that when you've got a build that takes 20 minutes, 30 minutes just to compile on a machine. When you have to use something like, God help us, Nix, because we need all the dependencies. Even Bazel takes you into this territory. Why are people excited about polyglot builds? You shouldn't need them, right? But oh, we have some JavaScript, and we have some Python, and we have some Java, and all these things together, and well, oh, isn't it wonderful that my build system can do all of it? Well, actually that's a yellow flag. If you need to build everything in order to have your system in place, in order for a front-end developer to be able to work on the website code, you've got a problem, right? And as operations people, I would encourage you very strongly to try and figure out where your boundaries are and make sure you create or do your best to create separation where teams can operate independently and take as givens everything around them except the part that they're working on. I didn't want to do a full rewrite. I mean, the fact that it was, patterns and styles and techniques that were done by other people that preceded my team, doesn't matter, right? Like, I didn't want to do a rewrite. We didn't want to spend 6 months plus of 16, 18-hour days grinding this thing out. I'd like my life back, please. But it's what we did. And why? Because I needed to be able to create the separation, to be able to use more modern techniques, to bring the energy level of the code base down. Because I don't work there, I don't have access to live screenshots of lots of it, but I do have a few fragments that were posted publicly. And here's one of them, old system versus new system. And the y-axis is not the same. And this was because the combination of, basically what they were doing is the outputs of functions, intermediate states, were being persisted in the database. That was somebody's idea of microservices. Put everything in the database, and the next thing could pick up the state from the database. So it was, in effect, an object being passed from one thing to another. It was actually a database write and read, which was why that. And so, you don't want to do a rewrite, but sometimes it's going to pay off, and it was nice that it did. And it was a success. I'm not here to talk about architectural patterns, but rather I need to highlight one thing, which is that one of the other big flags that something was horribly wrong was deployment frequency, which I alluded to a second ago. And we were able to go up by a massive amount, 300 plus PRs a month. I was able to get deployments up to 2-3 a day whenever we wanted deployment. Deployments took under 10 minutes after a build that was under 10 minutes. As a result, we were able to get things out to production quickly, which is actually, we don't quite talk about it, but Ms. Majors would have us all doing testing in production. That's awesome, but the key there is you need to be able to get your code to production quickly. Because if you can't fix things, change things, react to things. That's a theme we're going to come back to. Oh, and of course, not only were our users thrilled, but our Amazon sales rep was also thrilled that we reduced the bill so much. So this brings us to the topic of stability. As we were going through this, we had to figure out how to instrument code and what patterns to use and what good telemetry would look like and how it would be effective. And so one of the things that emerged out of this work was that stability is, in the observability space, I think unrecognized as being a very transient and local and brief phenomenon. And I think that anybody that's played the game that they might recognize on screen would recognize that stability does, it doesn't take much to wobble off and have fun. By the way, if you don't know what this game is, talk to me later. And so one of the, that seems like I just skipped a bunch of slides. No, yeah, no, we're right. Come back, come on. There we go. So one of the things that we end up doing is tracking requests, right? And wanting to log everything there is about a request, starting with the outer frame of when the API hits. And the accepted pattern is to put that into request.path in a telemetry frame. Great. So here's an API for getting the details for a user. And those are a few different patterns. The first one is the RESTful pattern, right? Object, and then a unique identifier, and then the field that would be associated with that. Same thing with a prefix up front, and then some sort of URL capture happening down the end. People that like REST would have done the first one, having tried the second one and thought that they could, because wouldn't it be nicer to have proper clean URLs? The third one on this one is the old way, right? We don't use query string parameters for user IDs. They should be in the URL for all the good reasons that REST gave us. Because we wanted to talk about nouns instead of verbs, right? Instead of RPC. Well, when you look at this, especially when you look at the first form, this is your mental model of what that endpoint is. User details. Oh, by the way, there's some URL capture in the middle, right? The second way is user details up front and then some URL capture on the end. And the third one is same deal, but off hanging in a query string parameter. In all three cases, your mental model of that query is user details and an endpoint. The endpoint is user details. So how many hits did you get? You put this into an observability system or any monitoring system, and you try to get, work out how many hits on the user details endpoint you've got, and you're done. You're baked. Because a naive system will look at that and see those as unique strings. Every single one of those is an endpoint. And I was horrified the first time I saw this, because I was assuming that it would naively take the context path without the query string. It didn't. Right? I'm sure the documentation said nothing of the sort, but I made that assumption, right? And, well, another deployment to production later. You've just a few different patterns we can go with here, but I actually had to go to some trouble in an HTTP library where I was doing logging was to cut off the query string and plonk it on the end and to isolate the path. And in fact, most systems would call path the whole thing. It doesn't really matter what definitions you use, but if that is the path is the whole thing, then you need a different term. I recommend root. Okay, but the reason I've got the beautiful RESTful style I've marked in red here is that much as I would dearly love to adopt the RESTful style, it really got in the way when I was trying to do telemetry, because there was no clean way for the HTTP library, which was well above where the context path was being constructed. Down below, 4 or 5 frames down, my library knew all about the structure of this URL. But the layer that was doing the logging, or capturing it, turning it into telemetry frames and sending it off to vendor of choice, had no clue. It's just a string, right? And so, much to my frankly disgust, I ended up back at the query string version. That was unexpected. And sure enough, then we ended up with beautiful traffic and lovely stats and so on. And so that was one where that pattern came up a bunch, which was because we say, oh, we can instrument anywhere, you can do it sort of orthogonally to an awareness of the application, there are limits to that. And that leads us to this interesting piece of advice in this wonderful book, which I'm sure many of you have come across and at least have the PDF of, if nothing else. And if you haven't cracked open the PDF, it's time for you to get reading, chop up. But one of the points that's made fairly early on is their definition of observability. And they kind of sneak in at the end this notion that, oh, and you shouldn't need to make a deployment to production. Now, the point that our lovely colleagues were making is that you should be able to get information out of the system without needing to make a production change. Sure, fair enough, right? And that's surprisingly apt because there are a couple of vendors out there where you need to pre-deploy the schema of what you want to look for before you can even conduct queries. Don't need to name names, but it's one of the significant limitations of the previous generation of logging and monitoring tools. So the point they were trying to make was, hey, you shouldn't need to do a build and deployment just to get new telemetry. Yeah, but my counter to that is that up front, you don't know what you need. And as you go, you learn. And so I think it's a little bit of a misnomer to say that, oh, you're going to have everything you need up front, because you iterate as you go and you learn different things. And so let's look at a couple of those. Here's one. Retries. And I thought I was being clever. I was like, every time I attempt to reach the voice transcription service, I will just log an attempt, and eventually I'll get one as long. And I ended up with waterfalls. And the real point of this is that it goes off the screen, right? Like somewhere down below, 400, 500 frames south of here, is the actual next frame of where what I'm looking for. Now, oftentimes, one of the surprising things that came out of all this voyage is right now I'm talking about trying to make good, coherent, nice traces. And the ironic thing is that having gone to all that trouble and achieved that, and having good, clear telemetry span traces of the nature I'm talking about right now, I almost ended up not needing it. And that was another surprise, is that the aggregate view, summaries, heat maps, and so on, that you get up top home in Honeycomb's parlance, is actually more powerful. But if you want that to make sense, attention to detail down here pays off. And once in a while, you do go and look at these, and it's nice for them to look nice. So, well, that was no good. There's another feature, which is span events. Everybody's really excited about that. You can create events which link into an existing span. And I tried that for retries, and that was another disappointing day. Half hour, but I was like, went all the trouble, rolled it out, and saw this. And I was like, oh. It was like crashed in, and oh, by the way, like the volume of events being created by this was slightly ridiculous. And there's no signal there, right? Like, yes, you can do this, but what have you actually gained? So this is interesting that, like, for all the work we've put into this particular piece of the observability pie, and OpenTelemetry supports it, of course, is I haven't been able to figure out a valid use case for span events. It seems like there should be there, but I haven't seen it yet. And I would love somebody to help me learn how to use it better. But that's the only place I landed with it. And so where did I end up? Just a field, just tracking how many times it had retried and whacked it in as a field. That was it. It seems like that's a little bit of a disappointment. And perhaps you'd say, oh, well, the tooling should know better. But then back to that theme that it's not as easy as it should be. The tooling only knows so much. For all that this stuff is, frankly, magical compared to where we've come from, there comes a point when you just need to compress it yourself. And that's where a certain amount of ability to retry and refactor things, and it becomes quite important. Another thing that comes up is one of the significant mantras in the observability space is high dimensionality of high cardinality events, right? That's axiomatic almost. I again feel like I need to pull us back from that a little bit, which is if you log everything, you end up with thousands and thousands of fields that you have to wade through. You're not doing your colleagues a good service if you just dump all this mess on them. And this was just sort of cooked up. It's contrived a little bit, but if you hook up the Kubernetes aid to pull data out of OpenTelemetry class data out of a Kubernetes cluster, you'll get a mess like this. And where's the one you need? And maybe after all, but that's one of those things that we're trying to get away from. Like if you need arcane knowledge to know that it's the fourth one that you really need. It's not name at all, you need label, right? That's the kind of bespoke knowledge that makes people feel valued and important, but is the kind of craftsmanship that we don't want, right? That's not helping your colleagues do their own exploration. Now, yes, people can discover the data. Yes, they can troll through it. But when time is ticking and things you're having some problems in a production situation, you don't want that. So I would actually advocate that some time and thought into managing the key space is worth the effort. It's the sort of thing you can do with your colleagues. It doesn't have to be perfect because you can iterate. But that's also, like, one of the things is, like, you write this data down, it's going to hang around for a while. I mean, some vendors expire after 60 days, but do they ever forget about the fields? And you get ever longer sets of completions, which, oh, by the way, this stuff is being thrown down to your web browser because it's doing most of the work. Their system's happy. It's just querying lists, easy, no problem. But the user experience can become slow. And the discoverability of being able to do a completion, dot, space, tab, whatever, right? That's very powerful. So managing the completion space of the keys of your telemetry has great value. So they told us this. So that's in terms of columns. What about rows? The lovely people at Hound Technologies Inc. Do this lovely thing where there's like, well, if you go over up to 3 days a month, you're fine. Well, you can go over if you get it wrong. I think that was a day when I was doing the span events thing. And it's very easy to blow out. And if you're generating that much traffic, well, first of all, that's going to have a cost implication for you at some point. Regardless if we create a big organization or small, there are limits. And the other thing is just how much data are you saturating in the system that's going to mess up your ability to understand the behavior of the system. One of the things that's not particularly obvious, but a number of systems at the top edge will give you a request count. But even that's confusing. Is it requests or is it spans? In Honeycomb's case, they actually toggle between the two depending on what they've seen in the data set, which is confusing, right? Because span count, what does that mean? That's completely meaningless as a metric, other than a broad notion of activity. That's the sort of thing that wasn't obvious. And then when the data sets did switch, because the default queries powering their home view did toggle, oh, okay, cool. It's not obvious that that was going to happen. And if you didn't know that was coming, you start optimizing for one thing, where you start thinking that a particular visualization doesn't have any value. Another thing to keep in mind is that as we're building traces and spans type telemetry, there are other sources of data which aren't going to be correlated, right? This is real, RDS, FTW. I don't know why they felt the need to put this into my Postgres logs. I don't know what it meant. All I know is that we all panicked when we saw it. And yeah, thanks. But worst of all, it was buried, right? Like this was in the detailed view of some Postgres logs of some particular instance that RDS didn't surface this in any way. This wasn't correlated to a request. There's no system I had that was surfacing this. And so that's one of the sort of final points here is, like you go to all the trouble of developing what you like to think is a coherent universal view of the system, but there are going to be other things that don't actually join in the correlation. It's easy to see problems, right? Well, here's a good one. This is audience participation time. Let's see if you can figure out where in this view the 5xx errors were showing up. You see it? I'll give you a hint. It's there. Do you see it? Yeah, no, I'm messing with you. The point is, and this is sort of a subtle one, but users who are experiencing errors stop clicking on it. You don't keep getting error rates from users who aren't pressing the button anymore. They try it once, maybe twice if they're stubborn, and that's it. And then your error rate drops to 0, and things are great, right? And now, if you're running a planet scale system with hundreds of thousands of events per second, you'll see the dip in usage and something goes wrong, sure. But early days, when you're commissioning a new system, somebody tries it a couple times, poof, gone, right? So it's something to keep in mind. What I encourage people to do in that scenario is like be attentive to any errors, right? So there's a mental shift, which is not what's the global error rate? Oh, it's under 5%, no problem, or some horrible number. Like, especially when you're commissioning 2 errors, that's a problem. This particular graph is, again, not to promote or beat up on Honeycomb, but they're just who I'm familiar with and the tool that I've used. This is a particular learning that I just wanted to share along. This is a result of a significant number of errors happening in the system that weren't visible at top level. And that's because we went to all the trouble of putting the magic error field on spans that were down the trace somewhere, 4 or 5 deep. No problem. I thought that was the way to be done. But the home screen visualization in that particular product only shows an error rate if it is at the top span. So you're probably bubbling an exception up all the way, whatever, but at the time, I had made the assumption that I've logged it down there on the span where it was relevant. That's going to give me my error rate. That's all I need to know. But blank. Oh. So no, I also had to actually log it at the top. And which then means you've got this duplication going on. Well, you've got database error with great detail down below, and then you've got error user class 4, something up top. And that was, frankly, a little bit frustrating. I still haven't quite figured out the right patterns there, because clearly you need the error down where it happened, but also you want the overall system to show that there's a problem correlating at the top. So not quite sure what to do about that. So where is this taking us? I think the biggest thing I wanted to pull out of that was that you learn as you go. The tools that you have will evolve. You're not going to get it perfect off the top. You're going to make schema changes to your namespaces, to the structure and shape of your spans, to the way you're treating spans versus requests, to the labels you use for things, the things you pick and choose to highlight in your boards or screens. And it's not continuous. There are discontinuities in that data set. And that's awesome, but it's also the immutable thing, right? You change an immutable data structure, it's a new data structure. Well, you change your data set, it's a new data set. And while that's awesome from a systems engineering standpoint, it's not cool from a reporting standpoint, because you can't build a reporting system on that. So here's here's the problem. We went and spent the better part of 2 industry decades collecting metrics off of systems in order to turn those metrics into pretty charts and graphs that we could put up on the walls and knocks. Yeah? And after 2 industry decades of work and massive amounts of effort on time series databases, collection, compaction, and visualization techniques, we got these pretty graphs on screens, and we realized that they didn't do us any good at all. I mean, they look pretty on the giant screens, but like you're trying to do correlations, nothing there, right? And that's one of the major impetuses that led us to the modern observability movement. Well, we taught ourselves that, and credit to the teams at Google that did the genesis of this, and others are contemporaries that came together, and we've now brought this up to be industry practice. The indicators that we use to observe the behavior of systems and to judge their behavior can be rated against the objectives that we've set for those systems, and that's how we define our performance, right? Major contribution point there is it's the observed and experienced usage by customers, users, consuming services that matters, not whether the CPUs are busy internally. That's a detail for us, not for the business. But can we derive that data from this observability stuff? And we thought we could. I mean, this is great, right? And those of you that have used this product would recognize this graph. If not, you can get the idea. This is the real deal, right? And, I had great aspirations of having gone to all this work. One of my major motivations was I wanted to get to the point where this was real, and I could take this to my colleagues on the executive and say, here's our performance. And my colleagues didn't care. This didn't mean anything to them. There's a couple problems. First of all, hadn't yet connected, as we'll go through in a moment, this to the broader business. But more specifically, this was a live view as presented by the particular vendor in question, but this is a live data set on something that's there's discontinuities in it. And so this isn't a reliable period over period view. I can't do a 6-month view of this if I keep changing the ways and definitions of this measure, right? There's no stability there. So as I said, my colleagues, I thought that things would be great, and this is how it ended up. Because here's what we think about, right? If let's say this was an SRE conference and we wanted to talk about how great observability was, we would talk about all these wonderful things. We measure and value and promote and try to optimize for these different factors. In particular, the one I've highlighted at the bottom. Most of what we're concerned about are our existing users, the experience and usage of people who are currently customers or consumers of our system. That's what matters to us. They're the people that are on it, right? But the broader business, broader organization, has slightly different concerns. Notably, that many of the people in the rest of the business are incentivized not by current user behavior, but by all the work that's needed to get new customers. And so right there, you've got a significant disconnect between all the work that's happening and everything that engineering is doing to have greater availability or better performance is kind of just implementation detail, and it's not that your colleagues and the rest of the organization don't care. It's just that it's not relevant to them in a pretty profound way. Because what they do care about is getting the features that they need, that have been promised to customers, to add capabilities so they can compete in the marketplace, right? Our competitor has this, we need it too, right? Significant driver of activity. And so, is it done yet or not? And if you answer that question with the databases are overloaded, you're not helping, right? And it doesn't mean that any of our concerns that I listed in the previous page are irrelevant. It's just that you've made a nonlinear transformation as you've gone up the scale. Here's what the person at the top of the food chain cares about, right? They have made commitments, and those commitments can be summarized usually on a few very succinct graphs, although the slide decks that carry these end up being really colorful and lots of pages. But the big one being for a small startup is ARR growth. And you're either, you've made a budget and you've got those targets and you're either hitting them or you're not. And that's it. And that then leads to questions like, do we really need these engineers? And I really should stop there. But, and in the first point, like the extent and sum of the entire technical conversation is it done yet? That's it. Yes or no. Did you deliver or not? And why does the CEO care about these things? Because the investors care about this thing, right? That's the metric that they care about, and justifiably so in our current economic climate and social structures and economic system. And so, you don't talk about database load to the investors, to the board, right? So how do we work this? Go to the bottom and come backwards, right? The economic imperatives of the people who invested in the organization, and by the way, like a lot of this vocabulary is somewhat small business centric, but frankly, it applies to large organizations, to NGOs, to government, right? People invest in outcomes, and you need to invest to achieve those outcomes. The person at the top of the organization is responsible for delivering those outcomes. That's the thing that matters. And so when you talk about analytics, right, the things that the business measures to know whether or not it's achieving its outcomes, its goals, those are the things you need to know about. Are we performing against our financial targets? Are we achieving the profitability, return on investment, whether, ethical outcomes, whichever it is, are we landing it? The top of the business, the executives need to know, are we delivering on the projects that we've committed to? Are we achieving our goals and internal financial performance, staff counts, which leads to financial cost, outcomes for customers? The business level, responsiveness would be the way I would summarize that. Are we able to deliver the features we need for our customers? Can we react to their needs? Are we being agile in the marketplace? Do we have what we need to make our customers and users happy? And so where does that lead us back into the engineering world? I think that the thing we need to care about, again, the word analytics, not observability, is culture. Do we have a culture of delivering rapidly? Do we give the things that our business colleagues need when they need it? Do we serve our customers? And all the availability stuff and all the metrics and everything else we have built is to land that, right? So where do we land? It's pretty simple in the end. All this work we put in, all the magic about observability, it's just a tool, right? It's not the end. That is the end. Ha! No, it's not. One more. Okay, so I've got something to go on the end. I want to talk just very briefly for a moment about what does it mean to be an engineer. And I get in big trouble because I walk around the world and tell people in rooms like this that all of you are engineers if you want to be. You don't need to have done it at university. You don't need to have a fancy piece of paper if you take responsibility for outcomes. Right? This is a working definition of engineering that I think is more useful than most others. And by the way, lots of people would have you think that engineering is applied science. It's not, right? Technology is applied science. Right? Engineering is when you take those things and put them to work for the purposes of the organization in the face of constraints, right? And if you don't have financial ability to do what you're delivering, if you can't do it so acceptably or ethically, then you're not achieving those outcomes. And the reason I bring this up is that for a long time, I didn't want to call what I was doing in corporate, some of you in my room are former colleagues, in banking, I didn't want to call it SRE. And we didn't call it SRE because honestly, that means something, right? And you're either doing it or you're not. And if you're not doing it, just calling yourself that on a business card doesn't make it so. Calling your team that doesn't make it so, right? It is, SRE is a philosophy of operations. It is a culture of taking responsibility for outcomes, of seeing things better. All the things we just talked about, right? And that sort of brought me back to what's the difference between one of the things I love asking people in interviews. It's not a right answer thing. Just like, is there a difference between a software developer and a software engineer? Software development is a rich field. It goes everywhere from theoretical computer science with its mathematical origins all the way through to the ways and methodologies we use, language choice, dynamic versus static, everything else that goes into it. It's a huge field. But that doesn't necessarily by itself have the connotations of taking responsibility for outcomes. You can do lots of software development and not achieve anything. Sorry. Sysadmin had sort of the same thing going on, right? There's plenty of people in the world who are brilliant systems administrators, many of our colleagues, who aren't engineers. They are experts in their thing. They can do their thing brilliantly, but they aren't necessarily the one to see something through to conclusion. And so when we're trying to define, well, what is it that we're trying to do, systems engineering seemed like the right label. It's a combination of both elevating systems administration to engineering in the same way I did with software development, but it's also the aspect of bringing software practices into the system space. As it happens, and this is an aside, there's actually an entire field of engineering called systems engineering, which is about something completely different, but it's surprisingly apt, and that's a talk for another day. But one thing that's, I think, I'm delighted by is recent efforts to take the terms that we've used, DevOps, systems engineering, SRE, and recently rebranding it platform engineering. I think that's brilliant, and I love it. And I think that the model still fits, and I'm delighted with that title. The reason I mention that is I got a new job. I'm working at a company called Talon. We work on something called Urbit. This is crazy stuff. Basically, take for a moment the idea that you have everything we've learned about computing and large-scale systems for the last 40 years as a given and start fresh. What would you build? And that's what Urbit is about. The company that I have joined is called Talon, that was founded to try and bring this to reality. It's a long-term project. But what do I find? Those bullet points look familiar, right? I find myself in a situation where I need to understand what our platform is doing on behalf of our users who have systems that are somewhat opaque. I need to increase the velocity of releases and to get feedback happening. And that sounds all a bit familiar, right? Well, my job title is to be head of platform engineering. And my mandate off the bat is permission to implement observability. So I have every confidence that I'll succeed. And not only that, but that acronym actually says something to me. It means I have hope. And so can you. And so can she. And that is the end.